This is part 2 of FFP2510 Codes and Standards, Chapter 8, Inspections and Hazardous Materials. Permitted control areas according to the International Building Code. Control areas must be a building or a portion of a building where hazardous materials are stored, handled, or dispensed, and the area is required to be fire resistant, rated for 1 to 2 hours, completely protected by fire doors, fire windows, shutters, and fire dampeners and fire stops, and the quantity is limited by exempt tables and control area location. A 1 to 2 hour fire separation wall must be constructed to the appropriate fire resistant rating design standard from the building code. Any openings for doors and windows must also meet the proper fire resistant rating and be self-closing. Control areas may be on any floor of the building, but the quantity of permitted material varies according to the floor. Control areas on upper floors must be supported by a structure with a 2-hour fire resistance rating. Ground or first floor, 4 control areas are permitted. Second floor, 3 control areas are permitted. Third through the 9th floor, 2 control areas are permitted. Above the 9th floor, 1 control area is permitted. All control areas shall be protected by a 1-hour fire barrier and floor sealing assemblies up to the 3rd floor. A 2-hour fire barriering and floor sealing assemblies from the 4th floor or higher. Here is an example of calculating the exempt amounts of flammable liquids allowed based on the protection type provided. Each control area is permitted different increases in exempt amounts based on the type of protection. Sprinklers and storage cabinets allow 100% increase of exempt amounts. Example number 1. The fire inspector inspects a 1-story factory, F1, use that it uses 1A flammable liquids in both production and storage. The building is a 1-hour fire-resistant construction and has 3 storage areas, of which 1 is protected by automatic sprinklers. 2 of the storage areas have listed flammable liquid cabinets and 1-hour fire barriers with a 3/4-hour fire door protecting all 3 areas. The owner asks how much 1A flammable liquid is permitted in the building under the fire code. Calculating the permitted exempt amounts. 1. Fire code allows 4 control areas on the 1st floor with 1-hour fire barriers and fire doors. Exempt quantity table allows 30 gallons of 1A flammable liquid in the control area. Determine the allowable increases for sprinklers and cabinets. Examples. Permitted amount is 240 gallons. According to this table, the factory owner could install additional flammable liquid cabinets in the storage room and handling area and increase the amount by another 60 gallons, or the owner could install the cabinets and sprinklers in the entire building and increase another 240 gallons to a maximum of 480 gallons of flammable liquids. If the 480 gallons were to be exceeded, the building would change use from a factory F1 to a high hazard H2 use. In this example, the factory has now added 2 additional floors and is using 1A flammable liquids in control areas on the 3rd floor. Control areas on the 3rd floor are reduced to 2 with a 50% reduction in permitted quantities. Cabinets and sprinklers allow a 100% increase of the reduced table quantities. Flammable and combustible liquid storage cabinets must be chemically compatible with the product stored inside them. They have quantity limits, usually maximum of 120 gallons. They must be properly identified as the chemical hazard. Flammable liquid storage cabinets listed under UL 1275 flammable liquid storage cabinets are limited to 60 gallons of Class 1 and 2 flammable liquids, 120 gallons aggregate as long as Class 1 and 2 limits are not exceeded. Typically, they're unvented to improve fire resistance, but are manufactured with plugs that may be removed to install vents that must go to the exterior of the building or to an approved exhaust hood for vapor removal. They're made of double-walled 18-gauge steel. The joints must be riveted or welded and are generally liquid tight with a 2-inch sill at the bottom to contain any internal leaks or spills. The doors should have a 3-point latching mechanism to ensure the doors remain properly closed when exposed to a fire. Flammable and combustible liquid storage cabinets are permitted by NFPA 30 Flammable and Combustible Liquids Code, but are not appropriate for corrosives or other materials. They're made of 1-inch marine-grade plywood, which must be rabbeted and fastened in 2 directions, and the doors must be rabbeted with an overlap of 1 inch and must have a 3-point latch and be tight-fitting. The cabinets must be painted with an intumescent paint to reduce the combustibility of the plywood. All cabinets must be properly identified as to the hazard of the material located in the cabinet with labels such as flammable, keep fire away, or the appropriate NFPA 704 markings. This slide has a video with a link in the bottom to allow you to view the video. Storage arrangements of hazardous materials are an important aspect of fire prevention safety that must be observed so that accidental chemical reactions do not occur. Storage should be by hazard class and compatibility. Incompatible materials must be separated by 20 feet or non-combustible barriers. Outdoor hazardous materials must be on a containment pallet and have weather protection. Non-combustible barriers must extend 18 inches above the highest container in the storage pile. If outdoor storage safety cannot be achieved, the hazardous materials must be placed in a storage facility that has secondary containment and spill control mechanisms. There must be adequate aisle space, storage must be secured from vandalism and motor vehicle impacts, and clear of smoking materials and combustible vegetation. Flammable and combustible liquids are the most common of all hazardous materials and are found in the widest array of buildings. They have vapor pressures less than 40 pounds per square inch absolute. Above that vapor pressure, material is considered a liquefied gas or compressed gas. Flammable liquids normally have a flash point below 73 degrees Fahrenheit and boiling points above 100 degrees Fahrenheit. They are always in a state ready to burn at normal ambient temperatures. Class 1A liquids have a flash point below 73 degrees Fahrenheit and a boiling point below 100 degrees Fahrenheit. Class 1B have a flash point below 73 and a boiling point at or above 100 degrees Fahrenheit. Class 1C, flash point at or above 73 degrees, but below 100 degrees. Combustible liquids have a flash point above 100 degrees Fahrenheit, but must be preheated to produce sufficient vapors to burn. Class 2 have a flash point above 100 degrees Fahrenheit, but below 140 degrees Fahrenheit. Class 3A has a flash point above 140 but below 200, and Class 3B has a flash point above 200 degrees Fahrenheit. Permitted quantities of combustible liquids are higher than flammable liquids. Thinner flowing liquids are likely more flammable. Viscous liquids are likely more combustible. Hydrocarbons are common but not the only flammable liquids. The combustible liquid K1 clear kerosene is blended with a flash point around 106 degrees Fahrenheit, but it's not that far from being a flammable liquid. The higher classification of combustible liquid, the higher the flash point. Thin, fast-flowing liquids are more likely to be flammable liquids as opposed to viscous liquids, which lean more towards the combustible side. Other flammable liquids. All electrical equipment and devices within range of flammable liquid vapors require protection with explosion-proof fittings as prescribed in the National Electric Code or NFPA 70. If flammable vapors are present, explosion-proof fittings on electrical equipment are required. The area must have spill control and secondary containment systems. Vehicle impact protection should be provided on above-ground tanks. Dielectric fittings or protective coatings on piping to prevent corrosion and leaks. Tanks and pipes also must be protected from galvanic action and corrosion by installation of dielectric fittings or protective coatings. If tanks are situated on permanent foundations, the foundation system must be at least 2-hour fire-resistant rating, and the inspector should make sure the combustibles and weeds are kept clear of the underside of the tank. Storage. Type of storage vessel and size depend on the hazardous liquids being stored. Tanks must be properly marked and labeled. Underground storage tanks require monitoring and secondary containment for leaks. Small quantities of hazardous liquids must be stored and used within control areas, and the appropriate storage cabinets complying with UL or NFPA should be used. Storage can also be in drums, portable tanks, and underground or above-ground storage tanks. Ignition source around the tank must be controlled. Monitoring systems must be installed as to detect leaks, and the secondary containment system must be in place in case of a leak. Overfill protection must stop filling at 90 to 95% capacity. The vapor space must be properly vented, and the vents must terminate at least 12 feet above grade level, at least 5 feet from any building openings. All storage tanks must be listed to the UL, ASTM, ANSI, or NFPA 30 standards for tank construction and use. Factory manufactured tanks may also comply with the requirements of the American Petroleum Institute, API, or the Standard Tank Institute, STI, for testing and use. All storage tank installations must meet the requirements of the local building code for backfill depth, tank monitoring, impact protection, and vapor recovery. Tanks must have overfill protection. Enclosures require properly vented vapor space. Tanks must meet industrial standards. Large above-ground tanks must meet requirements of NFPA 30. Firefighting foam systems are required if the shell-to-shell spacing is less than 50 feet or liquid surface is more than 1,500 square feet, or if one of the following is true. A, contains class 1 or 2 liquids. B, contains crude oil. C, located within 100 feet of processing equipment. D, possesses an unusual hazard due to topography or proximity to adjoining properties. Or E, boil-over liquids in storage tanks over 150 feet in diameter must also have gas inerting systems to protect them. Underground storage tanks may require secondary containment systems and fire protection with firefighting foam. Abandoned storage tanks must be made safe or must be removed. Dispensing and use. Flammable liquids can only be transferred by gravity or air pressure if the transfer system is specifically engineered for that purpose and an inert gas is being used. Flammable liquids flowing through air may build and discharge static electricity, causing an ignition and fire. Quarter-turn drum faucets, valves, should not be used when dispensing combustible liquids or other hazardous materials from 55-gallon drums and drum cradles. Inspection should ensure correct equipment classification and no cooking or heating appliances nearby. When processes require heating of flammable or combustible materials above their flash points, Fire Prevention Code require additional special considerations for safety distances to adjoining properties, as well as an increased level of fire resistance of the structure. Explosion control systems avoid catastrophic building failure by relieving internal pressure in a controlled fashion. Interlocks prevent the process from taking place unless all valves are in the proper position. If power fails, the valves remain in a fail-safe condition to prevent an explosion. Limit switches operate on temperature and pressure and ensure that the processes stay within specified temperature and pressure. If a limit switch exceeds its pressure or temperature, the interlock operates and the process is shut down. Parts washers must be UL listed, may not exceed liquid limitation. Remote solvent reservoirs may not be used for soaking and should have flash fire control systems. Multiple machines require proper ventilation and separation. Machines that recycle solvents by distillation must have operation manuals available and require larger portable fire extinguishers 40 BC or greater and located within 30 feet travel distance. Liquefied petroleum gas. It's a blend of propane, butane, isobutene, propylene, or butylene gases. It's liquid in the container but converts to gas once released. It's not to be used in basements or pits where vapors collect. The first LP gas standard was known as Standard 58 and was adopted by NFPA in 1932. The Fire Prevention Codes in NFPA 58, Standard for Storage and Handling of LP Gas, regulated the LPG installations today nationwide. LPG gas tanks must be protected and marked and identified using NFPA 704 placards. Storage tanks must be located with respect to building lot lines and public ways. They must have adequate spacing between cylinders for safety and inspection. Fire protection depends on the tank size. It must be protected from vehicle impacts. They vary in size from fixed tanks of 30,000 gallon capacity to portable tanks of 2.5 pound capacity. The Fire Prevention Code restricts the use of LPG in certain building use groups. 735 pounds per manifold in factories, additional manifolds separated by 20 feet. 50 pounds in research and experimentation for educational purposes, not to be located in the classroom. 12 pounds in institutions. Temporary use for public exhibition is limited to 12 pounds. Self-contained hand torches are limited to 2.5 pounds. LP gas systems over 400 gallons must have safety analysis and may require the installation of NFPA 15 compliant fixed water spray fire protection systems. LP gas installations exceeding 180,000 gallons must be protected with additional fire protection systems. Cylinders weighing 100 pounds or more must be marked with proper warning signs as well as the gas name. Installations exceeding 250 gallons must have signs indicating the gas supplier and the emergency contact telephone numbers. No smoking within 25 feet of No smoking within 25 feet of LP gas installations and combustible materials, and vegetation must be cleared within 10 feet of the tank. LP may not be stored in portable tanks on building roofs and will be limited for storage inside buildings. Generally, the buildings frequented by the public are limited to 200 pounds, and those not frequented by the public are limited to 300 pounds. Compressed gases can be flammable, non-flammable, poisonous, corrosive, or toxic. Fire safety depends on the nature and use of the gas. Valves and fittings for oxidizing agents should not be lubricated with oils. Proper hazard warning signs must be posted in the area where compressed gas is stored. Gases may be flammable. Hazards include fire and heat. Fire-resistant braided barriers, vaults, and clearance to combustible materials and the control of ignition sources around storage tanks is recommended. Leaks. Leak detection monitoring equipment, cylinder safety caps, mechanical ventilation of enclosures and storage areas, and containment equipment are listed in the code. If knocked over or impacted, it may become a missile or develop a leak. Codes require chains or nest cylinders and valve hoods to be in place when the cylinder is not in use. It should always be stored in an upright position, appropriate pressure regulator, no Teflon tape for metal-to-metal contact. All high-pressure cylinders of compressed gas must comply with DOT and ICC regulations for pressure relief valves, and hydrostatic testing of the cylinders conducted every 5 to 12 years. Typical industrial compressed gases include acetylene, ammonia, oxygen, carbon dioxide, chlorine, fluorine, hydrogen, ethylene, nitrogen, propylene, saline, methane, and MAP gas. Some of these gases are oxidizers like oxygen, chlorine, and fluoride, and while others are flammable gases like hydrogen and acetylene. Some may be inert gases like helium, argon, and carbon dioxide. Gas cylinders at facilities cannot be intermixed with hazard classes and must be maintained in safe storage configurations inside fire-rated storage rooms or gas cabinets. Gas cabinets must have negative pressure and monitoring alarms and windows and are limited to 3 100-pound cylinders. Gas vaults. Ventilation rates are usually a minimum of 150 cubic feet per minute, 1 cubic foot per minute per cubic foot of storage, whichever is greater. Outside, properly nested in triangles and kept out of the direct sunlight, secured in cages, those in use or storage should be secured to walls by chains and should be in stackable racks to prevent toppling. Cryogenic gases are extremely cold, minus 130 degrees Fahrenheit. There's a risk of damage to the skin on contact, and they should be stored in insulated vessels with pressure relief systems. They must be stored and used in compliance with FFP25 compressed gases and cryogenic fluids codes, which means kept secure from accidental dislodgement and physical damage, and only moved with compatible carts or trucks, and have limited controls to avoid overfilling. They must be properly marked and identified by NFPA 704 placards. Explosives are DOT Class 1 materials. They're regulated by both federal and state law and fire code requirements, and permits and licenses must be secured from the federal agencies. Division 1.1 is the most explosive and 1.6 the least explosive. DOT has 13 compatibility groups, A through S. These must be stored in special magazines. Used in mining operations, roads and tunnel construction, explosive demolition of buildings. Federal laws as well as the fire prevention codes regulate the possession and use of explosives. The Department of Homeland Security through ATF regulates explosives and since September 11, 2001, keeps tight control over their distribution and ultimate use. Licenses must be obtained before permits are issued. There are 6 divisions in explosives. 1.1 is mass explosion hazards, 1.2 projectile hazards, 1.3 fire and minor blast hazards, 1.4 minor explosive hazards, 1.5 very insensitive explosives, 1.6 extremely insensitive explosives with no mass detonation hazard. Example, commercial fireworks are 1.3G and are compatible for shipment with other explosives in Class G categories such as 1.4G pyrotechnics. Explosive magazines may be permanent or mobile, and they must be fire-resistant, theft-proof, and weather-resistant. Storage areas must be clear of vegetation. Magazines must have labels with signage. They must follow the American Table of Safety Distances to property lines. Magazines may include igloos, boxes, or semi-trailers and other mobile-type containers. Packing or unpacking of explosives may not take place within 50 feet of a magazine, and all tools must be made of non-ferrous or non-sparking metals. The American Table of Distances regulates the explosive storage in relation to buildings, public streets and highways, and other explosive magazines. Barricades around the magazine allow certain reductions in the safety distances specified in the tables. Distance tables become important during the explosive demolition of buildings and cities. Explosive detonators. This is a picture of non-electric firing systems connected to explosives wrapped around a column. Non-electric detonators are the safest. Electronic detonators can be set off by radar or radio. Loading of explosives is restricted to authorized personnel only. Licensed blasters must inspect for unexploded materials after detonation. Fireworks. Many states prohibit use of common fireworks except in public displays because of the high injury rate related to fireworks accidents. Discharge requires fire safety permit, and public displays usually require presence of a fire inspector and additional fire companies. NFPA 1123 established minimum safety distances to audience. Per NFPA, in 2009, 18,000 fires were started by use of common fireworks, resulting in $38 million in direct property loss. Per the United States Fire Administration, there were 8,600 fireworks-related injuries in 2010. NFPA 1123, Code for Fireworks Display, is for outdoor fireworks, and NFPA 1126, Standard for Use of Pyrotechnics Before Approximate Audience, is for indoor pyrotechnics and must be a distance of at least 70 feet per inch of shell diameter being fired. The wind must be at or below 20 miles per hour. 6-inch diameter shells or less can be fired manually by hand. Shells over 6 inches must be fired electronically from a remote location. Shells are fired from mortar tubes. Mortar tubes are cardboard, high-density PVC, metal, or carbon fiber. No materials that can fragment can make mortar shells. They must be a proper size and type for the shell being installed, and the shell should slip into the mortar easily. Mortars should be free of debris from the past discharges. Technicians can use flares to start smaller shells, but they must have personal protective equipment, fire-resistant shirts, hard hats, ear protection, and safety glasses. Cakes are small multi-mortar tube devices in a cardboard box. Misfires could occur from displacing mortar tubes if the box is not buried deep enough. Display cakes must be properly buried to a specific depth. Combustible material within the site must be controlled. Grass fields should be mowed and wetted. All mortars should be allowed to cool before any inspection is conducted for misfired shells, which should be done with mirrors. Unfired shells should be drowned in water, removed and packaged for proper disposal. First light sweep of a firing area should be also done to ensure that no firework devices have landed unexploded. Fire inspectors must maintain contact with the fireworks technician during the discharge, and tubes should cool before inspection at the end of the show. 1.4G pyrotechnics are used indoors during theatrical productions. NFPA 1126, Standard for Use of Pyrotechnics Before Approximate Audience, regulates proximate pyrotechnics. Usually 1.4G explosives involve theatrical productions such as concerts, sporting events, ice shows. Devices are small and are fired electronically on music cues. The audience must be at a safe distance in accordance with NFPA 1126. Adequate types and numbers of fire extinguishers should be present. Inspection should occur before allowing use. Fire officials should witness a demonstration of each device before approval for use. They must also ensure that surrounding materials are properly fire-resistant treated and that fire protection systems are not disrupted or reduced as a result of these devices being used. Wrap up. The following are federal regulations that manage hazardous materials: the Occupational Safety and Health Administration, the Hazard Communication Standard, HCS, the Environmental Protection Agency, Resource Conservation and Recovery Act, RCRA, the OSHA Hazardous Waste Operations and Emergency Response Standard, HAZWOPER, the Department of Transportation Hazardous Materials Regulations, HMR, the EPA Toxic Substance Control Act, TSCA, the EPA Clean Air Act, CAA, the EPA Clean Water Act, CWA, the EPA Emergency Planning and Community Right to Know Act, EPCRA. The following identify the different hazardous materials classification systems used in facilities. The OSHA Hazardous Communication Standard, HCS. The Globally Harmonized System of Classification and Labeling of Chemicals, GHS. The NFPA 704 Diamond. The DOT Hazard Classifications. The EPA Hazardous Waste Characteristics, and OSHA HAZWOPER categories. The following are the resources for determining the characteristics of hazardous materials. Safety data sheets, chemical database and websites, regulatory agencies, reference books and guides, chemical manufacturers and suppliers, professional organizations, training programs and courses. The following are the major categories of hazardous materials: flammable and combustible materials, oxidizing agents, corrosive materials, toxic materials, reactive materials. The following are the major inspection points necessary to prevent fires: storage practices, handling and transfer procedures, ventilation systems, emergency response equipment, labeling and signage, training and education programs. And finally, the following are the design alternatives permitted in building codes for storage, handling, and use of hazardous materials: segregation and separation, specialized storage cabinets and containers, secondary containment, ventilation systems, emergency response and evacuation plans, training and education programs.